Question is, a uniform electric field E naught is directly along positive y direction. Find the change in electrostatic potential energy of positive test charge Q naught when it is displaced from in this field from initial position A to initial position B along y axis. This is x axis, this is origin, this is y axis. This is the direction of electric field along y axis. E naught is the direction of electric field along y axis. Means direction of electric field is away from positive and towards negative charge. So in this case, ये negative field होगा, ये कहीं positive field होगा, like this. Now we have to find the electric potential, जो positive test charge Q naught when it displaced from point A. ये 0 A point हो गया, ये 0 2 A point हो गया. We have to find the electric potential energy as work done is positive, therefore delta U will be negative. So WIF initial to position minus delta U, that is Q naught E naught final position 2A minus A, that is minus Q naught E naught into A with negative sign. This is the potential energy as work done by field is positive, therefore electric potential energy decreases. This is the answer, right? In this session of electrostatic potential energy, we have gone through this. If you have any doubt, please comment. In this session further we are going to discuss all these things. It is requested, being very important for all these, go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल स्टेटस ट्यूटोरियल सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Now let's start with the question and concept. Question is, define electrostatic potential energy of a system of charges. Also derive an expression of electrostatic potential energy of a system of 2-point charges. First definition of EPE, electrostatic potential energy of a system of charges is defined as the total amount of work done in bringing the different charges to their respective positions from infinitely large mutual separations. Means infinity to that particular point amount of work done. Then further we have to find electrostatic potential energy of system of 2-point charges. Consider 2-point charges Q1 and Q2 lying at points A and B, and their locations are R1 and R2 respectively. These are the points A and B, R1 and R2 respectively. Firstly, the charge Q is brought to infinity to that point Q1. Charge Q1 is brought for to that point R1. There is no external field against which work needs to be done. So the work done in bringing Q1 from infinity to R1 is 0. Amount of work done bringing from infinity to this particular point is 0 because there is no electric field, no charges available there. Now V is the potential that has been set up by Q1. When it is present here, then V is the potential has been set up by Q1 at point B, where Q is to be placed. Potential due to point charge is given by this formula. Potential due to point charge is given by this formula, 1/4 pi epsilon Q1 upon RAB. distance between A and B. This is the potential due to a point charge. Due to a point charge. RF is the distance between points A and B. Now, by definition, work done carrying charge Q2 from infinity to point B is potential into charge. 1 over 4 pi epsilon, 1 over 4 pi is potential due to that point charge Q1, and this charge is being brought from infinity to that point. So this is the amount of work done. This work done is stored as electrostatic potential energy of the system of charges Q1, Q2, and mathematical expression comes out to be 1 over 4 pi epsilon Q1, Q2 upon RAB. RAB is the distance between the points A and B. Electrostatic potential energy is scalar quantity, and Q1, Q2 must be put up with proper signs. Important points to be noted. If Q1, Q2 is greater than 0, then potential energy is positive. It means that two charges are of same sign, they repel each other. Then in bringing closure, work is done against the force of repulsion. So the electrostatic potential energy of the system increases. Conversely, in separating them, work is obtained from the system. So potential energy of the system decreases. If Q1, Q2 is less than 0, potential energy is negative, it means two charges are of opposite sign, they attract each other. In this case, potential energy of the system decreases in bringing them closer and increases in separating them further. This is all about electrostatic potential energy and the mathematical expression for 2-point charges. Right? Next question. Question is, four charges Q1, Q2, Q3 and Q4 of these values are kept on the vertical square of side 1 meter. Find the electric potential energy of the system of charges. Find the electric potential energy of the system of charges. Electric potential energy of 2-point charges is 1 over 4 pi epsilon naught Q1 into Q2 upon R. इसमें गिवन है हमें माइक्रो कूलम में, इसकी वैल्यू 9 into 10 to the 9 into 10 to the minus 6, इसका कॉमन ले लिया, 10 to the minus 6 इसका कॉमन ले लिया, और जो वैल्यू गिवन है उसको एज इट इज पुट कर दिया. राइट? ऑन सिंप्लीफिकेशन दिस कम्स आउट टू 9 into 10 to the minus 3 into Q1 Q2 upon R. This is for 2 pi. This is the general concept I am applying to this. Right? Now, electric potential energy due to group of 4 charges or system of 4 charges, group or system of 4-point charges. In this case क्या होगा? Total number of cases will be NC2 कह लीजिए या n minus 1 by 2. ये होगा 4 into 3 divided by 2, that is 6 cases will be there. How? 1 over 4 pi epsilon naught कॉमन लिया, Q4 से स्टार्ट के ऊपर है, Q4, Q3, R43 प्लस Q4, Q2, R42 प्लस Q4, Q1, R41. 4 वाली सीरीज खत्म, अब 3 से स्टार्ट कर दिया, Q3, Q2, R32 प्लस Q3, Q1, R31. 3 वाली खत्म हो गई, अब Q2, Q1, R21. Right? On further simplification, this comes out to 9 into 10 to the 9. इसका कॉमन ले लेंगे, 10 to the minus 6 into 10 to the minus 6, ये कॉमन ले लिया. इसकी जो वैल्यू गिवन है हमें, ये 1 माइक्रोकूलम है, ये 2 माइक्रोकूलम है, ये -3 माइक्रोकूलम है, ये 4 माइक्रोकूलम है. 1 मीटर, ये डिस्टेंस डायगोनली होगी, √2 मीटर हो जाएगी, ये भी √2 मीटर हो जाएगी. नाउ विल सब्स्टिट्यूट द values. On substituting the values, 1 1 2 2 3 का नेगेटिव है, 4 का पॉजिटिव है बस. Q4, this comes out to be 9 into 10 to the power minus 3. Q4 Q3, 4 into minus 3 upon 1 plus Q4 Q2, 4 into 2 upon R4 to root 2 plus third one Q4 4 into 1 upon R1 4, that is 1, R1 4, 1 2 3 4, 1 3 and 2 4, that is all. 1 plus 1 2 3 1 plus Q3 minus 3 into 2 upon R3 2, R3 2 is 1 plus minus 3 into 1 upon root 2 plus Q2 2 into 1 upon R1 2 1. On simplification, this comes out to be 9 into 10 to 1 minus 3. ये simplify हो क्या रहेगा minus 12 upon 5 root 2 joule. That is on simplification minus 7.62 into 10 to 1 minus 2 joule. This negative sign indicates that work done is positive. Work done is positive. Amount of work done is positive in bringing the respective charges to their respective location from infinity to that point. Right? Now question. Question is 2-point charges are located on the x-axis. Q1 equal to minus 1 microcoulomb at x equal to 0. Q2 equal to plus 1 microcoulomb at x equal to 1. Find the work that must be done by an action force to bring a third point charge Q3 plus 1 microcoulomb from infinity to x equal to 2 meter. Another part is find the total potential energy of the system of 3 charges. Concept applicable in solution. Amount of work must be done on Q3 by external force to bring Q3 at position 20 in the presence of Q1 and Q2. Work will be equal to final potential energy minus initial potential energy. That will be equal to 1 over 4 pi epsilon naught Q3 Q1 upon R31 plus Q3 Q2 upon R32 plus Q1 Q2 upon R12 minus 1 over 4 pi epsilon naught Q3 Q1 R31 plus Q3 Q2 R32 plus Q1 Q2 R12. This is final potential energy. This is initial potential energy. Initially, because you know x equal to 0, infinity से Q3 charge आ रहा है 1 microcoulomb. This is 20 position. This charge is to placed at this point. Q2 is 10 meter and this is 00. Q1 is minus 1 microcoulomb. So R31, R32 are like this. So this will be infinite initially. This will be infinite initially. So this expression, whole expression will become 0. This whole expression will become 0. And this will be carried out by this one. So balance is 1 over 4 pi epsilon naught Q3 Q1 upon R31 plus Q3 Q2 R32. Substituting values 9 10 to the power 9 into 10 to the power minus 6 times 9 10 to the power. This comes out 9 10 to the power 9 10 to the power minus 6 into 10 to the power minus 6. Q3 Q1 1 into minus 1 upon 2 plus 1 into 1 upon 1. 1 into 1 upon 1. This comes out to be 9 10 to the power minus 3 minus 1 by 2 plus half, that is half. On simplification, this comes out to 4.5 into 10 to the power minus 3 joule. This is the amount of work done. This is the answer of part A. Right? Now part B. Part B के लिए क्या करेंगे? Find the total potential जो होता है system of 3 charges. B part. Total potential energy of system of 3 charges. 3 charges. This comes out to be 1 over 4 pi epsilon naught Q3 Q1 R31 plus Q3 Q2 R32 plus Q1 Q2 R12. That is 9 10 to the power 9 into 10 to the power minus 6 into 10 to the power minus 6 upon 1 into minus 1 upon 2 plus 1 into 1 upon 1 plus 1 into minus 1 upon 1. On simplification, 9 10 to the power minus 3 upon minus 1 by 2 plus half. This comes out to be minus 1. This goes, so this comes out to be minus 1 by 2 into 9 10 to the power minus 3. That is minus 4.5 10 to the power minus 3 joule. This is the answer. Right? Now, I would like to request, if you are new to my YouTube channel, City Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.